Okay. So one more topic in matrix theory would be quadratic forms. Um, what's the definition of a quadratic form? Is a homogeneous polynomial of second degree in any number of variables is called a quadratic form. Usually you can be asked to define a quadratic form as well for 1 or 2 marks. Um, a quadratic form in n variables is given by this equation, right? Now, coming to example. How does a quadratic form look like? Many of you know. Standard example will be ax square plus 2hxy plus b square, by square. Okay. Now, what exactly I'll be doing, why I'm discussing this quadratic forms in matrix theory is I'll be writing the real symmetric matrix of a quadratic form and handle the quadratic form. Basically, the idea here would be to convert a quadratic form to canonical form. Quadratic form to canonical. What is a canonical form? If you know, then what exactly I am doing is what you will understand. Usually it is called sum of squares form. That means what? I'll be having only the terms which have squares and not the combination terms. Okay, how will I write the matrix for this quadratic form? Now it would be something like this. I have two variables x and y. So the first term will have xx quotient. Second term will first row second element will have xy quotient. Second row first element will have yx quotient and yy quotient. Okay. So coefficients, actually these are all coefficients. Okay. Now here xx means x squared quotient is a. Similarly, y squared quotient is b. Now coming to xy quotient, I have xy quotient to be 2h. Of course, I have yx quotient also I needed to construct the matrix. So I'll have this 2h. I will half it. So I'll be having h. So one h I will put here, the other h I will put here. Any combination terms are handled like this only. The coefficients to the squared terms would be in the diagonal. Okay, so what exactly I will do to construct the canonical form of a quadratic form is I will make all the remaining elements to be 0. Make in the sense I'll perform elementary operations or use. There are basically in literature there are two methods. One is linear transformation, the other one is orthogonal transformation. Here I'm going to discuss linear transformation. Linear transformation. Okay. Linear transformation to reduce quadratic form to canonical form. Okay. Yeah. What is linear transformation? I will just give an overview of the linear transformation. Now, how will I write? Please see here. I'll be writing like this, the quadratic form. There's another way of representing quadratic form as well. It would be x transpose ax. I will just show. Suppose if this is there, how will I write this equation? I will just show. Let capital X is equal to xy, right? In the above example. So X transpose would be what? What would be X transpose? XY. It would be the row vector. If I've considered capital X to be the column vector, then X transpose would be a row vector. You all know, right? X transpose AX, if I consider, X transpose is XY row vector. A is AH, HB, X is XY. Any two things first you multiply, I'll be going with the last two, XY. So I'll be having what? A into X plus H into Y. A into X plus H into Y. That would be my first row. Second row would be what? H into X plus B into Y. H into X plus B into 1. Now, I'll finish off the multiplication with the row vector as well. So what I will get? X into A11 element, Y into A21 element, right? A x square plus hxy, okay, plus the second one I'm multiplying with y. So hxy plus by square. That's it now. Here x into a11 plus y into a21. Right. Now this would give me the quadratic form. 2hxy plus y square. Okay. Right. Now this is my quadratic form. One way of writing quadratic form is in x transpose ax. Now, what's linear transformation? Let me give an overview in this video. What we will take in linear transformation is let x is equal to py be the transformation, because all are in the power 1. It is called a linear transformation. Anyways, now I'll be substituting x is equal to py. Then what I will get would be py transpose a py. Okay. So y transpose p transpose a py. Okay. So this would be what y transpose. I can call p transpose ap to be some b into 1. This is the linear transformation, and this would be called canonical form, provided B is a diagonal matrix. If capital B, that is equal to P transpose AP, is a diagonal matrix, then we call Y transpose BY would be canonical form, right? So what I should do? I should find such P transpose AP, for which what we will do, I will just explain in a problem. Okay? Yeah. Now, there's also little more things which are important for the exam in quadratic forms, that is index and signature. Index, signature of the quadratic form. What is index? Index is nothing but you denote index by small p, number of positive terms. Number of positive terms, remember, positive terms in the canonical form. In the canonical form, okay, would be called index. Now, what's a signature? Signature is nothing but the difference between the positive terms, or actually it is said like this: more number of positive terms over negative terms. More number of positive terms over negative terms. Okay. Yeah, usually it is called like that, or in other words, it's the difference between the positive and negative. See, terms in canonical form, by the way, by default, it is positive terms minus negative terms. Right? Okay. Now see, I have p number of positive, if I have p number of positive terms, now I'll be reducing the quadratic form or the canonical form to echelon form or normal form. Normal form or echelon form will be reducing. So I'll know the rank, right? So rank minus positive terms would give me negative terms. So what I will have will be 2p minus r would be called signature. Of course, this is at a next level. Usually these things are useful for the gate, but normally you'll be asked to find index and signature, and you will look at the number of positive terms, say index is this much. If you are asked also to find the signature, the difference between the positive terms and negative terms you will take. If you ask me, ma'am, if there is only one positive term and there are two negative terms or three negative terms, if it is like that, then obviously I will write -1 would be the signature. There is no hesitation about writing -1. Okay, that means what? There are no positive terms. Negative terms are more. So signature would be -1, right? Now, depending on index and signature are found for the canonical form of the quadratic form. Or index and signature we decide after reducing the quadratic form to canonical form. Also, there's something called nature of the quadratic form. Nature of quadratic form. What is nature of quadratic form is there are basically 5 types. First is positive definite. These are important, guys. Though they are very small things, positive definite. They are very small things. They'll help you to fetch marks in the exam. Okay, positive definite. Positive definite is what? If all the terms, if all the terms in canonical form, not quadratic form, guys. Directly, we don't say anything after reducing to canonical form only. For all the terms in the canonical form are positive, then you will say the quadratic form is positive definite in nature. Okay? Yeah. Now, there's something called positive semi-definite. Positive semi-definite. Okay, what is that? Positive semi-definite is what? If I have zeros, comma, positive terms. Okay. Some zeros can be there, positive terms are there. Combination of zeros and positive terms in canonical form. If I have, then I'll be calling it to be positive semi-definite. If you are clear with this, negative also follows similarly. Negative definite. What is negative definite? Negative terms. Negative terms in canonical form. If all the terms are negative in the canonical form, then you call that canonical form to be negative definite in nature. Okay. Negative semi-definite. Negative semi-definite. What's that? Same thing. You have zeros and negative terms in the canonical form. Terms in canonical form. Right? Huh. You can ask me, what if none of this are followed? I mean, randomly, there is a zero eigenvalue, there's a positive eigenvalue, also there's a negative eigenvalue, kind of things. Then what we will call is, it would be called indefinite. Indefinite. Okay? What is indefinite? All are not positive, all are not negative. Zeros are there, positives are there, negatives are there, or usually positive and negative both are there. Then in such a case, you will call the canonical form to be indefinite. Okay? Yeah, please do remember these things. Definitely they are going to fetch you 1 or 2 marks for the exam. Okay? I shall do a problem in the next video.